Hello, how we doing? We're gonna move on with 6.9 today. We're gonna use our fundamental theorem of algebra. Yes, it is strange that it's taken us this long to get what we're gonna call the fundamental, the basic theorem of algebra, but yet here we are in the middle of January, finally getting to such a thing. So all it says is that our biggest power, our degree of the polynomial, tells us how many total real and imaginary solutions, zeros, roots, whatever you want to call them, how many different answers we're gonna get. Um, Really, it only stands for the total amount. That includes everything, um, positive normal numbers, negative numbers, i's, square roots, all that kind of stuff. So it doesn't mean that they're all going to be good easy ones. It just means that's how many total different roots there's going to be. So like one of those semester exam questions, how many different zeros are we going to have? Possibly 5. Find our biggest power, circle it, 8. That's it. So this is one of those semester exam questions you should have got right, and it's really all we have to do. So now that we know how many different answers there's going to be, now we need to think about our complex zeros, those things involving I, those things involving square roots of 3 or 5 or other ones that we don't know. What's nice about them is they're always going to come in complex conjugate pairs, which really just means the plus or minus. You know how we always end up with answers like 4 plus or minus 2i or whatever? Well, they always end up in a plus and a minus. So that's all this is saying. If we know that one of the plus ones is there, then the minus one has to be there also. So you're going to get a real easy question on your exam that's going to say, hey, we got this answer, and this answer. Well, since there's 4, there's one missing. Well, what's that one that's going to be missing? Well, you look at your weird one, the complex one, the square root or the I, and you find the opposite. So the opposite of positive square root of 5 is going to be the negative square root of 5. And that means the other answer has to be this one, because these two need to match. So same thing here, example number 4. If we've got negative 4 and we've got this 2 plus 3i, what's the one that's missing? 2 minus 3i, because things with i's always come in the pairs of plus and minus. So we just write that one out. Here, example 5, we've got a 2i and a 3i. Well, what's missing? A negative 2i and a negative 3i. And yes, this seems like, man, this can't really be that easy. Yeah, it is. That's really it. Moving on here. Example number 6. It says 2 is a 0. What is the factor? The factor means what is the parenthesis group that that's associated with. Well, if it's a positive 2, that means the factor is always going to be the opposite, negative. So we're going to write x minus 2. Because if we did x minus 2 equal to 0, we would add 2 to both sides, and we would get x equals 2. And that's why this is the 0, but this is the factor. So when it asks us what's the factor of this particular 0, or we need to use that later on, probably on the next lesson or today, then this is what you need to do. Just change the sign, put it in a parenthesis group. So, hey, these things are all zeros. What are those factors? Well, a minus 2 is going to become an x plus 2. A plus 3 is going to be an x minus 3, and a x minus 5. So we take our zeros, which are, where they cross the x-axis on our graph, or the different solutions, and then we can write out our different parenthesis group factors, and then if we wanted to, we can multiply it out and find out what our x cubed blah 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 kind of answer is. So that is what they're going to ask us to do now. So now we want to find our function that is this. So we're going to do a little box method. It doesn't matter which two we pick first. I'm going to pick these two. So x plus 2 and x minus 3. We're going to do our box method because it is what we do. We do box method. Minus 6. So that gives me an x squared. These two are going to leave a minus x and a minus 6. So again, we're going to box method this with the last parenthesis group that we did not use, our last factor of x minus 5. Leaves us x cubed now, minus x squared minus 6x, and so forth, plus 5x and plus 30. So now we're going to put our like terms together, get us x cubed here, minus 5x squared and minus x squared is going to make a minus 6, or 7, yeah, 6, why did I write 7? Because I'm an idiot, that's why. X squared, Put these two here together, that's going to be minus x and plus 30. So we got x cubed minus 6x squared minus x plus 30. And I apologize for that hideous 6. I don't know why I decided that needed to be a 7. Alright, so just when you thought multiplying stuff like that was done, here it is. Find our polynomial function with these things as zeros. Well, first thing we need to do is write out our parenthesis groups. A minus 1 is going to become a plus 1. And then our 2i and minus 2i is going to be x plus 2i, x minus 2i. Now, since we need to find our polynomial, we need to multiply this. A little trick: if you multiply the two things with the I first, it's going to make things easier to multiply by your last one. X plus 2i and x minus 2i. Hopefully we remember that that is our plus minus difference of two squares kind of thing going on. If we don't, we can still do box method because it always works. And minus 4i squared. And hopefully we'll notice the 2i and the minus 2i is going to cancel. Leave me with x squared. Minus 4i squared, the I squared cancels and changes the 4 to a plus, so that becomes plus 4. Alright, we multiplied these first because is there an I left? No, and that makes things easier. So let's multiply by x plus 1, x cubed now. Look at these powers going up, which they should because we've got 3 solutions, so we need at least an x cubed. Plus 4x out here, plus an x squared here, and plus 4. So our final answer here is x cubed plus x squared plus 4x plus 4. You do want to make sure that we write our answers, our polynomials, in descending order of power, meaning big power, smaller and smaller powers as we go on down. So we got x cubed plus x squared plus 4x plus 4. Alright, they're going to ask us to do that same type of thing here again. I would highly suggest take a moment to pause and give it a try on your own, see where you get stuck at, but I'm going to work it out for you anyway because that's the kind of guy I am. I love working with polynomials. Even on the weekends, you know, it's just probably what I'm sitting around doing. I'm just multiplying some polynomials. Alright, we're going to multiply our 2 with the I on it first. That's going to give me x squared minus, not 4. What am I doing? That's minus 16i squared. Using my pattern, know that I square the front, square the back. Now, the I squared is going to cancel and change that to plus, so I've really got x squared plus 16. And multiply here, x minus 3. And what's that, 48 minus 48? Alright. So we got our x cubed minus 3x squared plus 16x minus 48. Oh yeah, look at that guy. That's kind of an ugly polynomial. But it is what it is, and that's where we are. Alright, our sample CCSD question, and then I think we are done here. Look at that record time. We're just moving quick. Alright, so it says according to our fundamental theorem, how many zeros do we have? Well, oh yeah, this is that easy one from our semester exam. 4. That's it. We don't need to worry about anything else. Alright, that's all we got for you. I promise you our next one is going to be a whole lot more fun. It's what all this stuff is really working for. So make good choices out there in the world, and we'll see you back in class.